Good evening, guys. Am I audible and visible to you all, everyone? Am I audible and visible? Hello, hello, hello. Good evening, everyone. Ouch. Am I audible and visible to you all? Okay. Okay. Is it crystal clear? Yes, it is crystal clear. So, as you all know, yesterday a small soft launch went on, right? About the Neet 50 days challenge. Good evening, everyone. Sat Sri Akal. Are we forgot our entry. Hello, bachcho. Sat Sri Akal and Namaste from my side. This is your own physics educator Indrajit Singh welcoming you all into the PW English channel. Right? Yes, I will teach you from scratch. Right? Lots of things are going to come in this today's session. Yeah, it will be only English. Right? Yesterday, you all know, the small soft launch went on for the 50 days challenge. Right? 50 days challenge for the upcoming NEET examinations. Right? Okay, अरे हाँ यार ठीक है चलो कोई नहीं. ठीक होगा. 20 सेकेंड्स लेगा आई थिंक. रिफ्रेश करो. आ गया. Hello students, am I audible and visible to you all? Hello. ये विघ्नेश को मैं यार इसको हटा देते हैं परेशान. Am I audible and visible? Sorry, a small glitch went on. Okay, is it now okay, everyone? Those who are live. Okay. So as you all know, the small soft launch went on right in yesterday's session, and we took a challenge, 50 days NEET challenge. So in this session, lots of things are going to come. I'm going to give you all the mind maps of this session. We are going to solve the sums. We are going to understand the theories. We are going to see the live simulations of it. Right? It things goes awesome na when live simulations comes in front. Right? Things goes awesome when the mind map comes in front. Things goes awesome when the questions are going to come in front. Yeah. We will definitely discuss if any kind of the trick exists. We are definitely in motion under gravity, lots of tricks are there. In graph based question, lots of tricks are there. Right? Yeah, we will cover 1D, 2D both. In 2D, riverman, rainman problem, lots of tricks are there. Right? Okay, Harika says, sir, use China brush. Acha, chalo, theek hai. Okay. So shall we start? Everyone, those who are live can have the answers into the comment box. Right? So the agenda of today's session is kinematics. In this sense, we are going to cover 1D and 2D both. Okay. We are going to cover 1D and 2D both. Right. Are you all ready? Everyone, those who are live can have the answers into the comment box, please. We will make physics. See, physics is not an 1 minute process. You can't understand physics into the 1 minute, right? So you have to wait till end. This is what physics is all about. You have to wait till end. You need, see, we can't judge the picture by seeing first 10 minutes. You have to see the entire story. Likewise, we can't judge the physics session, right, at the very moment. In 1 second, hey, yeah, this sir is not good. No, we can't do like that. This sir is not good. He is having very long beard. It's not like that. You have to wait. You have to stay till end. You have to understand what actual content we are receiving and then judge. Right? Okay. So as per Neet syllabus, the entire 50 days challenge will be divided into 20 units. Among them, the first unit is kinematics 1D. Okay. First, we are going to see the mind map of those chapters, and then slowly, we are going to start the rest of the things. Okay. So among the number of the students, those who are watching, those who think that this sir is this, please bring that and this, guys, please, it's your choice, right? Okay, we haven't kept gun on your head. You're not on the pinpoint to watch this lecture, right? Please. Okay. So generally, if I'm talking about 1D motion starts with the basic terminologies. The basic terminologies means what? We are going to discuss about distance. We are going to discuss about displacement. We are going to discuss about velocity. We are going to discuss about average velocity. We are going to discuss about speed, right? We are going to discuss about average speed, right? Acceleration, average acceleration, right? This all are the basic terminologies that are used into the 1D. Okay? Understood everyone, those who are live? Okay. So these are the very basic terminologies. As we are dealing with motion in one dimension, right? So I have included this much terminologies. Apart from this, we will be having the force, right? Lots of things are there, but later they will be discussed later on. Okay, as the syllabus continues, the rest of the physical quantities will be introduced. Now, the second thing jumps on to motion, right? Okay, you can also say that second thing jumps on to the motion. Now, how we are having further bifurcation of the motion? First, the type of the motion that we are going to discuss will be uniform motion. What is the meaning of uniform motion? I think now I am perfectly audible and visible. Right? Okay. Now I am perfectly audible and visible. Right? We are living into the technical worlds and we are having some glitches, right? Okay. So, the first part, that's a uniform motion. Uniform motion, it means simply speed is constant. Right? Uniform motion, it tells nothing about distance, it tells nothing about displacement, it tells nothing about average velocity, average speed and everything, right? It only states that uniform motion, the speed is constant. The second type of the motion that is known as uniformly accelerated motion. In this uniformly accelerated motion, we are having the simple explanation as acceleration of the system is constant, and when acceleration of the system is constant, we are having the three equations. Right? So these are the three equations in which the acceleration of the system is kept constant. Right? Now, on another side, it comes motion under gravity. Where acceleration is constant but it is negative g. So these three equations can be written as v is equal to u minus gt, s is equal to ut minus half gt square, v square minus u square is equal to 2gs. So this is what the classification of the uniformly accelerated motion goes on. Basically in this chapter you are going to deal with three types of the motion. First is uniform, uniformly accelerated, third is non-uniform motion. Right. So here third type of the motion comes upon as non-uniform motion. Right? Non-uniform motion. Understood everyone, those who are live? Can have the answers into the comment box please. Now third bifurcation of this mind map goes on to the most important method that is applicable to all kind of the motion, that is calculus method. That is what? Calculus method. Right? That is what? Calculus method. Understood everyone, those who are live? That is what? Calculus method. After calculus method, basically there are three formulas included into the calculus method. A is equal to dv by dx, v is equal to dx by dt, right? And acceleration is equal to dv by dt. Whether it is a uniform motion, non-uniform motion, uniformly accelerated motion, whatsoever it should be or whatsoever it may be, right? The entire calculus method relies on these three formulas. Okay? And the final bifurcation, okay, that went on graph and graphs conversion. Entire motion into 1D, right? Entire motion into 1D is covered in this mind map. Okay. See, we are into the last 50 days challenge. If you are expecting that into the 2 or 3 hours of the lecture, we will do differentiation also, right? तो अभी तक आपने क्या किया है? The polishing of the Neet content is going on, right guys? Polishing of the Neet content is going on. So please understand the sensitivity of this lecture. Are you all okay with this? Everyone, those who are live, can have the answers into the comment box. Everyone, fast. And now what we are going to do, we are going to see lots of numericals of the 1D. And through each and every numerical, see, if I'm going to tell you all the theories and then we will do the numericals at the last moment, then it will be the very lengthy process. But once we are going to see the numerical and through that, we are going to revise the theory, it means that in each and every numerical, we are revising the whole chapter. So that's called an reverse engineering and we are going to follow that. Each and every sum will come. In each and every sum, I will explain you the whole theory. So through this, we will be having the two benefits. The entire theoretical part will also be covered with the revision, in this session only, and lots of numericals we are going to solve. See, directly one question will only come from this chapter, but indirectly this kinematics is useful in all, in entire syllabus. Okay, shall we start, everyone? In the diagram shown, a particle moving from a point A to point B, length of each arrow is 1 meter and the particle is moving with a constant speed. What is the displacement? Displacement. Okay. So before solving this numerical, let's move on to the distance, displacement, okay. Now we are going to see the terminologies that are associated with the uniform motion. Okay, terminologies that are associated with the uniform motion. First, distance. Second, displacement. Speed. Velocity. Average speed. Average velocity. Student always used to get confused in between these terminologies, and we are going to clear all of those terminologies in one shot, and beneath to that we will define a uniform motion. Done. Distance. Total length of journey, which is sometimes it is also known as path length. Distance is always positive, it can't be negative. What is displacement? Shortest distance between 2 points. It can be positive, it can be negative, it can be zero. Sweet, sober, direct explanation. What is speed? Speed is the factor that is associated with the distance traveled by time is speed. Always positive. Velocity, displacement by time. As displacement can be positive, negative, zero, the velocity can be positive, negative and zero. Average speed is total path length by total time. Generally, average speed is taken into the calculation in those cases where entire journey is broken in multiple parts. You might have heard about this question. Particle starts for 2 seconds with this velocity and then moves for 3 seconds, then this velocity, and then moves for 4 seconds with this velocity. For this kind of the questions, right, the entire journey is broken, okay, into the multiple parts. In that case, average speed is calculated. And what you want to tell about the average velocity is displacement by time. Right? Understood, everyone? So this is what the very basic explanation of the distance, displacement, average speed, average velocity, right, and distance is all about. Okay. Now, if I am going to tell you all about the uniform motion, then we are having the very simplest explanation of the uniform motion. The speed of the particle is constant. It means the ratio of distance by time traveled is constant. This is only the simplest explanation of the uniform motion. Right? This is only the simplest explanation after the uniform motion. Now what does the question demands? When particle moves from A to B, what is the shortest distance? Each length is 1 meter, 1 meter, 1 meter, 1 meter. They are saying what is displacement? Displacement, see, this is an initial point and this is the final point. As we discussed, displacement is the shortest path between the initial and final position. This is what we have discussed now. Shortest. You can guess shortest distance, you can say shortest path. Right? You can say shortest path between the 2 points. Okay. So what is the shortest path? 1 meter plus 1 meter. Your answer is 2 meter. Okay. The question was quite easy, but it was kept at the beginning of the session to make you all aware about the process that we are going to follow for the entire session. Right. Okay. So this is the question and this is the theory revised. Let's move on to the next question. Again, see, from the same, the numerical ratio of distance or a displacement to distance covered is always. Can you have the answers into the comment box? See, we have to find the numerical ratio of displacement to distance. Right? Displacement is the vector quantity. As we are dealing with the 1D motion, so as of that reason we aren't introducing the vectors. But displacement is actually the vector quantity. And here the new aspect of the theory is coming. Can I have the answers please into the comment box for this? Can anyone try? The new aspect of the theory is, right, distance is always magnitude of displacement. Distance is always the magnitude of the displacement. Suppose let us take an example. If I am saying r is equal to x of I plus y of j plus z of k, the 3D vector is given. Suppose they are saying this is a displacement vector, right? Then magnitude of this will be the distance. So what is the magnitude? Under root of x square plus y square plus z square. So here the possibility arises that if it is displacement or distance ratio, the maximum value of the displacement can be distance. You can also say that maximum value of the displacement is distance. So as of this reason, this ratio is going to be less than equivalent to 1. Understood everyone? Those who are live can have the answers into the comment box please. Yes or no? Is it cool? Right? This was a theory, this was a uniform motion that we understood from the first sum. This is the new aspect. See, whatever the new things that are coming up in front, you can just write down at the bottom like that way, right? Okay. Let's move on to the next question. See, the car travels a distance d on the straight road in 2 hours and then return to the starting point in next 3 hours. Entire journey is broken, right? Or entire journey is divided into multiple parts, right? This is what I said now here. The concept of average speed comes when entire journey is broken, like it is divided into multiple parts. See, same theory for the third question. So with each question, we are revising the same theory thrice and we are solving the numericals also. So this is the power of the reverse engineering, and this is what we are going to do into the Neet 50-day challenge. A car travels the distance d first time interval in 2 hours, then returns to the starting point. It starts from A to B and then returns to the starting point. It means it travels the same distance in 3 hours. See, the entire journey is divided into 2 parts. So as of that reason, they are asking you to calculate the average speed. Okay. So what is the formula of the average speed here? The formula of the average speed, that is equal to total distance, right, by total time. So total distance is d plus d, total time is 3 plus 2. Okay, your answer is 2d by 5 meter per second. Understood everyone, those who are live? Was it easy or not? Can I have the answers into the comment box from the number of the students, those who are watching this session live? Right, guys? See, the same theory. Average speed, total path by total time. Okay. Let's move on to the next question. Now, particle starts its motion from rest under the action of constant force. Here comes the new thing. Here comes new thing. How it is so possible you can introduce the force in 1D? Kinematics is that branch of the motion in which study is done without cause. Study is done without cause, without understanding the cause of the motion, right? We are, see, you are being a student, you are an observer. I am an observer. Let us take an example from the very day-to-day life, right? Ideally, you are sitting, as usual, I used to take the same example in my app batches. Ideally, you are sitting, scrolling up the Instagram. Teri baaton mein uljha. So your motion before 50 days of Neet might be, like, someone might be analyzing this motion, na? Who's the one? Mama. All the time, parlo, 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 parlo. And you all are like, ulja jiya. Right. So who's the frame of reference? Frame of reference, the observer is a frame of reference. Who? Mom in this case is a frame of reference. Right. Who is the subject? I am a subject. What I am doing? Performing motion. Like that. So in this case, whenever the frame of reference observes the motion to the subject, he never thinks about the cause. Right. Instead of mother, if the observer might be your brother or something, जाने देना, fail होगा. Now who is going to tell him again and again? He is not going to be serious. But instead of your brother or someone else, it's your mother. If it would be your brother, he would be your brother. He will think without cause. If it would be your mother, she would be your mother. She will think with cause. So many students might be thinking, as we are dealing with the kinematics motion in 1D, how cause will come? Constant force, it means we can say it here as F is equal to ma. Force, if force is constant, acceleration is constant. So indirectly they are telling us about that acceleration is constant. If acceleration is constant, then what kind of the force is going to come within? If acceleration is constant, then this is purely the case of uniformly accelerated motion. What is uniformly accelerated motion? A very simple, very awesome example I'm going to give you all in front. One example, entire topic will be fitted into your head. Acceleration of the particle is constant. Velocity increases or decreases at uniform rate. What is the meaning of the velocity increases or decreases in the uniform rate? What is the meaning of this uniform rate? Uniform rate, it means what? Suppose particle starts from rest. If in first 5 seconds velocity is increasing by 5 meter per second, then in next 5 seconds also it will be increasing by 5. In third, fifth second it will be increasing by 5. In fourth, fifth second it will be increasing by 5. Okay. Suppose particle starts from rest, t is equal to 0, u is equal to 0. In first 5 second it increases by 5. Then in next 5 second also it will be increasing by 5. In third 5 second also it will be increasing by 5. In fourth 5 second also it will be increasing by 5. So this is the uniform rate of increasing into the velocity. Similarly, uniform rate of decrease in velocity will come. So whenever we are having this kind of the motion, we must say it is in a uniform accelerated motion, and 3 equations are associated. S is equal to ut plus half at square, v is equal to u plus at. Okay, this equation you have to apply when you have to find velocity at any time. This equation you can apply when you want displacement at any time. And this equation is applied when you want to find anything between 2 time intervals. Should I give you the best example? Have you heard about the music? Sorry, being into the pure English class, right? I can't sing that Western music. So I'm just giving you the example of the uniform accelerated motion. The velocity is increasing at the uniform rate. तड़प तड़प के इस दिल से आह निकलती रही. Velocity is constant. तड़प तड़प के इस दिल से आह निकलती रही. Velocity is constant, uniform motion. तो लुट गए. Velocity is increasing with respect to time. तो लुट गए. Velocity is decreasing with respect. This is the best example of the uniformly accelerated and uniformly decelerated motion. See, velocity is increasing. It is starting from rest. It is increasing. तो लुट गए. हाँ लुट गए. Right? we are first, Priya beta, we are first seeing the concepts only and then we are solving the sums, right? Anna beta. So this is the case of the uniformly accelerating motion. Did you all understood the concept? Can we move on to the sum? You just have to think about the acceleration is constant. Wherever the acceleration is constant, you can apply these three equations. If acceleration is constant, velocity might be increasing or decreasing at the uniform rate, you can apply this equation. Acceleration constant, you can apply this equation. Acceleration constant, you can apply this equation, or you can remember, लुट गए, हाँ लुट गए. Now they are saying, see, if the distance covered in first 10 seconds is S1 and covered in first 20 seconds is S2, simply here time distance, we have to use second equation. Right. So S1 is 0 as it starts from rest first 10 seconds. So S1 that will be A by 2 into 100, that is 50A. Can I consider this as equation number 1? The distance for the first 20 seconds is S2. Right. So 20 is equal to 0 plus half A, 20 whole square, S2. So S2 is equal to A by 2 into 400. So S2 is equal to 200A. Can I consider this as equation number 2? They are telling us to find the relation between S1 and S2. So can you all tell me the perfect answer? S1 by S2, that is equal to 1 by 4. S2 is equal to 4S1. Understood, beta? Everyone, those who are live can have the answers into the comment box. So from this question, right, we understood, right, from the previous 2 to 3 questions, we understood the concept of the uniform motion. Now from this, right, we understood the concept of the uniformly accelerated motion, right. See, everything is having the preparation scenario. If you are joining the batch from the beginning and preparing for 2 years, see, first of all, I am going to clear out that thought. It is not possible to teach the entire 2-year content in 3 hours. If you are thinking that entire 2-year content should be taught in this, that is not so possible, right? And whatever the thing that we are doing here, it is best. Understood, beta? Everyone, those who are like, okay. Let's move on to the next question. See, speed of the 2 identical cars are u and 4u at a specific instant. See, this is a specific instant. Car A, car B. Speed of the car A is u, speed of the car B is 4u. It means initial speeds are given. Right? Initial speed, it means at t is equal to 0. T is equal to 0 means the point where observer starts observing its motion, right? Okay. Observer starts observing its motion. Muskan Nazia, then why you write score 700 plus? You can. Whatever the content we are discussing, it is capable enough to polish your knowledge, right? No one is blamed here and no one is misleaded here, right? You can, right, beta? But if you are expecting only from one session I will score 700, then your own psychology is wrong, right? the ratio of the respective distances when two cars are stopped. See, here they are talking about the concept of stopping distance, right? Here they are telling us now what is an actual meaning of the stopping distance. Stopping distance means quite simple, right? Stopping distance, it means, see, practically speaking, when acceleration is in direction of velocity, it increases the speed of the particle. And when acceleration is in opposite direction of the velocity, it decreases the speed. When acceleration and velocity both are into the same direction, it will increasing the speed. And when acceleration and velocity both are into the opposite direction, it will decrease the speed. Understood? So here stopping distance comes when particle starts moving with the initial velocity, acceleration retards, it is into the opposite direction, and velocity decreases at uniform rate. Velocity decreases at uniform rate, and after some amount of the time it stops. So here if I am using the third equation of motion, right, final velocity becomes 0. This is the formula of stopping distance. Stopping distance is nothing else but the accelerated motion only. Stopping distance is just one of the application of the accelerated motion only, right? Stopping distance is just one of the explanation of the accelerated motion only. Here in this case, the difference is acceleration is only negative. In uniformly accelerated motion, acceleration and velocity are into the same direction. So it increases the velocity. तो लुट गए. And when acceleration is opposite direction to the velocity, हाँ लुट गए. It is a retardation, deceleration, both are the same words. So this is a concept of the stopping distance, and now we are going to use this into the formula. See, from this formula, can we say the stopping distance is directly proportional to u square? So can we say S1 by S2 that is equal to U1 square by U2 square, UN 4U. So S1 by S2 that is equal to 1:16. Answer is quite easy. Once you are able to understand the concept, the things are quite easy. Done? Everyone, those who are live can have the answers into the comment box. Is it done? Can we move forward to the next question, guys? You all are enjoying now? You all are enjoying the explanation and the way of teaching now? Average velocity of the car between two cities 20. If it moves with 50 for half of the total time. Okay. Now here in this question, we are going to introduce the new things, right? See, in case of uniform motion, Two special cases are there. In case of uniform motion, you all know what uniform motion is. Uniform motion is speed of the particle is constant. Now we are not talking about the uniformly accelerated motion. Still many students are thinking, sir, why you jumped on from uniform to uniformly accelerated? Now again you are going back to uniform. Same happens in Neet. Right? Same happens in Neet. If you are expecting the first question of the Neet is going to definitely come from units and measurement, wrong. Second question will be definitely from 1D, wrong. Third question would be definitely from 2D NLM, right? If they are going to follow the sequence, wrong. Anything may come upon any time. If you are having a habit to deal with things like this, then and then you will feel comfortable into the Neet examination. See, in Neet examination, what happens? One side your 2 years of the preparation and another side 3 years of exam. Sometime exam pressure is at so peak that the 2 years of the preparation is at full stake comparing to the 3 hours of the examination. And this happens only into the case, right? Okay. This happens only into the case when you all are not perfectly aware about an exam environment. So why here things are going on randomly? Because we are if particles start from A, ends in B, entire journey is divided into two equal distance intervals. This is the case of two equal distance intervals. This distance interval V1, this with V2, then average speed it is given as 2V1 V2 whole divided by V1 plus V2. This is spatial case number 1. Now we are moving forward to the spatial case number 2. Instead of two equal distance intervals, right, here comes equal time intervals. So in this case, average speed or velocity, it is given as V1 plus V2 whole divided by 2. So whenever the two equal distance intervals are given into the question, you can use this direct formula. When the equal time intervals are given, you can use this direct formula. Right? So here in this question, they have mentioned half of the total time. See, kindly focus on the journey. The entire journey is divided in two parts. The entire journey is divided into two equal time intervals. For first half time intervals, this is a velocity. So it means directly we are going to use the formula average velocity or speed, that is V1 plus V2 whole divided by 2. The total journey is 200, is 50 plus V2 whole divided by 2. So what will be the V2? 350 meter per second. Right? So the diagram appears like for first time interval, for second time interval. Right? This is with 50. Right? And this is with 350. Understood everyone, those who are live? Right? Understood guys? Are you all live? You all are breathing? All are breathing now? Yes or no guys? You want this peg? No? It's not a peg, right? It's just a water. You can just see and it's just a water. Okay. So this is the theory, the special cases of the uniform motion. Right? Can we move forward? A car starts from rest and accelerates uniformly. See, accelerates uniformly. It means it is a case of uniformly accelerated motion. Among these three equations, we are going to get the answers. It starts from rest, reaches to 180 in 10 seconds. Then distance covered by will be what? Particle starts from 0, reaches to 180 km per hour in 10 seconds. I think he is traveling Bugatti. He is traveling through Bugatti. And the Bugatti, what? Aston Martin. Right? In 10 seconds, it goes from 0 to 180. And a 0 to 180. 0 to 180 would be like to lut gaye. 0 to 180. 0 to 20 would be like to lut gaye. 0 to 50 would be like to lut gaye. 0 to 100 would be like to lut gaye. And 0 to 180 would be like to lut gaye. Initial velocity is 0. Final velocity is 180 km per hour. Right. So if I am converting 180 km into 5 by 18, so your velocity will come upon in 50 meter per second. So initial velocity is 0. Final velocity is, right, 50 time. See, they have said that it is a case of uniformly accelerated motion, but acceleration value is not defined. If we are unable to define the acceleration value, how will calculate the distance? So first step is, from the given data, find the value of acceleration. Right? Final velocity is 50, 0, acceleration into 10. The particle is getting accelerated by 5 meter per second square. Oh, we got our acceleration. It is constant. Now what we need to calculate? Distance covered by the car in time interval. Distance covered by the car in time interval. For distance, we can use this equation. U is 0 in 10 seconds. This is our answer. Understood, everyone, those who are live? Right. Is it easy or not? Is it easy or not? Again, car starts from rest, U0, accelerates uniformly. It is a case of uniformly accelerated motion. Why we converted? You can keep in kilometer per hour. See, time was in seconds, right? Generally, we are solving maximum numericals into MKS system. Time was in seconds. Suppose if you are not converting the velocity from kilometer per hour into meter per second, right? Then converting time from second to hours will be the time consuming process, right? You can understand. Again, see 144 kilometer in 20 seconds. The distance covered in 20 seconds is the same procedure we need to follow. Can we do that, everyone, those who are live? If you want to convert kilometer per hour to meter per second, you have to multiply by 5 by 18. Or if I am going to give you all the shortcut, on every 36 kilometer per hour, you will be having 10 meter per second. 72 kilometer per hour, 20 meter per second, right? In between 36 to 72, you will be having 5 meter per second, 15 meter per second. On multiples of 36, 10 meter per second, 72, 20 meter per second, 144, 40 meter per second. So this is a shortcut trick that will save your time into an examination. Can we do this sum by ourselves? Everyone, those who are live, can have the answers into the comment box, please. We can do it by ourselves. Yes or no, everyone, those who are live. Right? Which of the following relation representing displacement particle with a constant acceleration? Calculus method. The previous question I gave you all in homework because it was the same procedure that we followed into the, right? See, the same procedure that we followed here. The procedure that we followed in this question, the same we are going to follow in this. So I've given you all in homework. Now we are going to see the different aspect of the uniformly accelerated motion, that is a calculus method. Boom. Entire calculus method depends on 3 important formulas and a trick. Entire calculus method depends on 3 most important formulas and the trick. The first most important formula is A is equal to V dV by dx. The second most important formula is V is equal to dx by dt. Among these 3 formula only, the entire calculus thing is defined. Among these 3 formula only, the entire calculus thing is defined. And with this, one trick. If you are following top to bottom, if you are going from displacement to velocity, velocity to acceleration, you have to do differentiation. If you are following bottom to top approach, you have to use integration. So this is the trick and this is the formula. One side we will be having a trick, on another side formula. Understood everyone, those who are live? Okay. Differentiation of displacement always gives velocity. Differentiation of the velocity with respect to time always gives acceleration. Integration of acceleration with time always gives velocity. It gives change in velocity, right? And integration of velocity with respect to time, it always gives the displacement. Understood everyone, those who are live? Right. So let's see what they are saying into the question. Okay, see, from this calculus method only, you can define the uniform motion, the uniformly accelerated motion, non-uniform motion, all kind of the motion into the 1D can be defined by this calculus method. Whether it is uniform, uniformly accelerated and all. पढ़ तो लो फिर बोलना ना, right? Let this entire 50 days challenge should complete and then see revolution in yourself. This is what I said into the beginning of the session. Now, please don't judge into the first 15 minutes, 20. See, 1 hour of the class has been, 1 hour is crossed. 1 घंटा चला गया. Time flies, right? You all are enjoying now, everyone, those who are live. See, we need to check it out in which equation acceleration is constant. See, suppose if I am taking equation number 3, x is equal to 9t square by 8. Differentiating this equation with respect to time, it is equal to 18t, right? And acceleration will be 18 meter per second square. In the third, each and every equation of the displacement is given, right? Each and every equation of the displacement is given. Each and every equation, each and every option, you have to differentiate it twice to reach up to the equation of the acceleration. Because see here, displacement is given and we have to reach up to the acceleration. Displacement is given and we have to reach up to the acceleration. So what we have to do, we have to follow the top to bottom approach. Displacement, velocity, velocity, time, acceleration. So you have to differentiate twice this equation, twice this and this, right? Each and every option you have to analyze with whatever the data that is given into the question. So from this, third is only the thing, right, in which we are going to have, after differentiating it twice, we will be having the constant value of the acceleration. So third is a perfect answer for this specific question. Understood everyone, those who are live? See, if a train traveling at this speed is brought to be rest in distance of 200, what is the retardation? Can we use direct formula of stopping distance? Yes or no in this question? Can we use the direct formula of stopping distance? Yes or no in this question? Everyone, those who are live. Everyone. If a train is traveling at the 72 km per hour and it is brought to be at rest in 200 meters, then its retardation should be what? Directly can we use the formula na, S is equal to u square by 2a. Retardation is equal to u square by 2s. What is u? 72 kilometer. It means it is 20 meter per second. 20 into 20 whole divided by 2 into 200. 1 2 1 2 1 कटा, दूसरा कटा. Retardation is 1 meter per second square. stopping distance. Train stops in 200 meter, it means stopping distance is given. Right? Understood everyone, those who are live? See, X denotes displacement. Acceleration is what? Which approach we need to follow in calculus? Top to bottom or bottom to top? Displacement is given, we need to find the acceleration. What approach we need to follow? Top to bottom, bottom to top? Can you all answer into the comment box, please? Can you all answer into the comment box? X is equal to a cos of t. Differentiating with respect to time, we will get velocity. Differentiation of cos is minus sine. Right? Again, differentiation of velocity with respect to time, we will get acceleration. Is negative of a cos of t. This was a very simple question based on write the calculus method. Very simple question based on the calculus method. Understood everyone, those who are live? Yes or no? The displacement of the particle is given by this two equation. Acceleration of the particle is what? Again, displacement is given, we have to find the acceleration. You only tell me, top to bottom, bottom to top. Now you are capable enough. Displacement is differentiating with respect to time, 4t plus 2. Differentiating with respect to time, अच्छा नीट में जेई एडवांस क्वेश्चन किसको करने हैं? The JEE advanced students are not going to come in this sessions, right? Because this is a NEET based thing is going on. Again, position of the particle varies with respect to time. Acceleration at the time t of the particle will be equal to 0. They are asking at what time acceleration is going to be 0. Displacement is given, x is equal to at square minus bt cube. They are asking at what time acceleration will be 0. Top to bottom, bottom to top. We have to reach to the acceleration from displacement. So we need to follow top to bottom approach. Right? Okay. So velocity will be what? Velocity is 2at minus 3bt square. Acceleration will be 2a minus 6bt. We need to make it as 0. So 2a minus 6bt is equal to 0. Right? So 2a is equal to 6bt. So the time at which the acceleration would be 0. 2 3s are a by 3b. This is the perfect answer for this specific question. Understood everyone, those who are live? See again displacement. Now they are asking what will be the what will be the velocity when acceleration is 0. Can we do this by ourselves? Yes or no? Everyone, those who are live. Can we do it by ourselves? Yes or no? Everyone. Top to bottom approach. Find out the equation of acceleration. In that, find out the time. Replace the time into the equation of the velocity to get the final answer. That's it. Huh. Now we are coming upon to the case of the motion under gravity. Motion under gravity. Shall we start? The most important, lots of tricks into the motion under gravity are going to come. अरे कोई उसको 100 रुपए दे दो यार. Please give him. Okay, unique. First of all, चलो जानते हैं. The stone thrown upwards with you from the top to bottom reaches the ground. Height of the tower is what? Motion under gravity. Motion under gravity. Lots of tricks are going to come. Okay, the motion under gravity is simply as like particle is thrown with some velocity, it goes up, follows the same trajectory and comes down. Do you want the live simulation of it, everyone? Do you want the live simulation of this? Guys, do you want the live simulation of motion under gravity? See, particle is thrown with the initial velocity into the upward direction. See, okay, I am decreasing the velocity so that you are all are able to understand. See, are you all able to analyze? Are you all able to analyze? Yes or no? Everyone, those who are live. Object is thrown from the bottommost surface. The object is thrown with some velocity. It follows the straight line trajectory and retracing, right? It comes back retracing the same trajectory. Okay. Same simulation we are going to see for the projectile motion. Okay. Same simulation we can see for the horizontal projectile motion. oblique projectile motion, horizontal projectile motion, motion under gravity. Are you all able to understand? Being an observer, you are the observer. Being an observer, whenever you are trying to analyze this, right? Whenever you are trying to analyze this and writing down into the papers, it is equivalent to studying physics. पैसा है, पैसा लगता है, पैसा. In this world, there are no free lunches in life, right? But this always gives the feel of physics, right? This always gives feel of physics, right? Now see what happens into the case of the motion under gravity. See, motion under gravity, what happens in this case? See, there is a ground, particle is thrown upward with the initial, it reaches to the max height and retracing its path, it hits the same point, right? It is given some velocity, it goes into the upward direction, reaches the maximum height, it retraces its path and hit back the same point, right, with the same magnitude of the velocity, but the direction is reverse. So here, as Galileo said that this kind of the motion always comes under the constant acceleration, that's why we can say it as this motion is motion under gravity. Motion under gravity, motion under gravitational force. There is a force, there is an acceleration from the center of the earth that tries to pull every object. There is an acceleration that tries to pull every object towards the center of the earth. As of this reason, it is known as the motion under gravity. Understood, everyone? Okay. So as acceleration is negative, okay, but it is constant. So we can apply the we can use these three equations. Okay, now what are the tricks into the case of the motion under gravity? See, whatever the things goes up, same comes down. If the object is thrown with 10, it will hit back with 10. If the object is thrown with 20, it will hit back 20. When the object is thrown with 30, it will hit back with 30. When the object is thrown with 40, it will hit back to 40. And there is a trick. If it is thrown with 10, it will reach max height in 1 second. If it is thrown with 20, it will reach the max height in 2 seconds. If it is thrown with 30, it will reach max height in 3 seconds. 10, 1 second. If it is thrown with 20, 2 seconds. If it is thrown with 30, 3 seconds. This is a trick. And at max height, the final velocity is always 0. Understood, everyone, those who are live? Right? Now, this question states that this question is a bit different. it says that a stone is, see, there is one tower of height h. A stone is thrown upward with the velocity u. It travels to the max height and hit back the ground with velocity 3u. And we need to calculate the top of the tower. If the velocity is given with which the particle is thrown in upward direction, then it is quite easy to calculate the time of flight and time to reach the max height. Right? Understood? Okay. Understood, guys? So here what we are going to do, this is the initial point. In between initial and final point, we are going to apply the third equation of motion. Final velocity is 3u square, 9u square. Initial velocity is u square, negative of 2g, h is the height of tower. 8u square is equal to 2gh. So h is equal to 4u square by g. So this is the value of the height of the tower. Understood, everyone, those who are live? Right, 8u square by g, okay, is the height of the tower. Understood? It is array. Sorry. 4u square by g. My mistake. Four u square by g. Okay? Understood, everyone? Yeah, by my mistake. So through this question, we have revised the concept of the motion under gravity. Now through this question, we are going to revise all the concept of graph. A body is projected vertically upward from the surface of the earth. Its velocity versus time graph would be what? See, graphs of uniform motion. What is the meaning of uniform motion? Speed is constant, right? So it means what? The x versus t graph would be like this way, right? V versus t graph would be like this way, and acceleration would be, time would be 0. This all are the graphs of the uniform motion. King of physics. Oh, right. The next comes the uniformly accelerated motion. Right. Xt graph is like this way. Velocity versus time graph is like this way. Acceleration versus time graph is like this way. Acceleration is constant. In uniform motion, speed is constant. In uniformly accelerated motion, acceleration is constant. Right? Okay. In non-uniform motion, nothing is fixed. See, these are the standard graph. If something different comes, right, from the standard procedure, you all might be thinking, na, the question what they are asking is not a part of the standard procedure, right? Then what you are going to do? There might be some way. So in this case, what you have to do? If any graphs comes on extraordinary, different from the standard graphs that are given into the NCERT, what you have to do? You have to trace the value at each and every point. Trace, trace the value at each and every point. You will get your answer. You will definitely reach up to your answers. See, this is a ground. From ground, the particle is thrown upwards. Here the velocity is maximum. Means it starts from here. The graph starts from this position. Slowly, 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 when particle reaches the max height, velocity is 0. It means from ground to max height. From ground, when it starts and reaches to the max height, velocity becomes 0. From ground, it starts. When reaches to the max height, the velocity becomes 0. It means here velocity is decreasing to 0. Now when it comes back, see, velocity is the vector quantity. When it was moving up, the velocity vector was in upward direction, so we took it as positive. Now when it is retracing its path, the direction of the velocity is downward. So we will take it as negative, right? So when it retraces its path, velocity is increasing, but it is increasing into the negative direction, right? So like this way, point to point, you have to trace the value of the physical quantity and plot the graph. Now still many students are thinking, sir, why the graph is a straight line? Why it is not a curve or something? Because velocity always follows this equation. Right? So as of this reason, the second is the perfect answer for this specific question. Second is the perfect answer for the specific question. Understood, everyone? Everyone, those who are live, can you have the answers into the comment box, please? Arey yaar, how it is going to start from 0? Suppose the velocity, no velocity is given to the particle, then how it is going to reach max height? If some velocity is there at the bottom, then and then it is going to travel some distance and reach to the max height, na? Tayyabba, Parveen. Particle starts from rest and moves with the constant acceleration. It velocity displacement, see, standard graph. V square minus U square is equal to 2AS. Parabolic graph. This is the equation of parabola. Y square is directly proportional to X. Equation of parabola. Equation of parabola. For this, v square is directly proportional to s. For this, v is directly proportional to x square, according to the standard equations of the parabola. Array, this is the velocity versus displacement for the constant acceleration is constant. It means we have to use the third equation of acceleration. Array, third equation of the uniformly accelerated motion. The third equation of uniformly accelerated motion only defines the relation between velocity and displacement. Understood, everyone, those who are live? Which of the following velocity time graph shows a realistic situation? Which is the realistic situation? You only tell me. Analyze the graph and tell me the realistic situation into the comment box, please. Everyone, those who are live, please. And yeah, please do share this session maximum in your groups with your friends and all. See, time always moves in forward direction. How it is so possible time moves back? Time always moves in forward direction. How it is so possible time moves back? In this 3 graph, time moves back. This is only the graph in which time is moving in forward direction. Sometimes you have to think logically and get the answers, right? Sometimes you have to think logically and get the answers. From the following time versus displacement, find the velocity. Oh, very simple. Slope of displacement versus time graph is velocity, yes or no? Slope of displacement versus time graph is velocity, but here time versus displacement is given. So slope is equal to tan theta, that is equal to velocity. But here as it is time versus displacement, so here 1 by slope will be equivalent to velocity. Reverse graph is given. If it would be displacement versus time, then slope will be velocity, then it will be tan theta. As the reverse graph is given, 1 by slope, 1 by tan theta is velocity. So velocity is equal to 1 by tan 30. Understood, everyone, those who are live? So this kind of the tricky, I must not say tricky, catchy, right? The questions are also coming up into an examination. Calculus method. Find the nature of the acceleration. X is equal to bottom to top, array, top to bottom. Velocity is 2t plus 4. Acceleration is 2 meter per second square. 10 seconds, right? Question is solved. Distance clear, displacement clear, velocity acceleration, average acceleration, uniform motion clear. These three equations are clear, right? Uniformly accelerated motion, non-uniform motion, it's okay. Calculus method is clear. We have seen some graph based questions. See, practically you all are mature, right? That there is a difference in the 3 hours of the or 2.5 hours of the lecture and the huge preparation. So here this lecture has been kept you all to polish. To score 650 or 700 marks is not a one time process. It is an entire journey. Slowly, right, you are raising yourself, right? Okay. Now one says, you sorry sir, but you are little bit higher. जाना तेरे को जो समझता है समझ. You are really an immediated. No, क्या बोलूं? You are judging in 1 minute. ठीक है जो बोलूं. Okay. Now I am going to give you all the mind map of motion in 2D. Now 2D is having vectors. See, speed is more than fine. You can say it is an appropriate. You also know, see, if I'm talking about our regular classes, if I'm talking about our sessions, even if I'm talking about our droppers session, okay, we took one lecture to explain the entire concept. You can't eat chappan bhog in 1 second, na? You can't eat chappan bhog even in an hour, because your stomach is not having that much volume to eat, to acquire the chappan bhog. You will spit out, right? So this all sessions are kept for you all to polish your knowledge. See, I am not a culprit if I am saying truth. I don't want to make you all, right, into the false hopes, right? 700, 720 is a journey that starts from suddenly 50 days before the Neet. The student who has already crossed the 2 years and reach here, and now anyone wants to jump. Even in this case, luck is not going to support, right, beta? So this kind of the sessions, right, are just to help you all for right, polishing your knowledge. At least you know something before and after this lecture. Everyone, yes or no? Those who are like. The first part of 2D goes to the projectile motion. Basically, 3 types of projectile motions are there. Right. Basically, right, 3 kind of the projectile motions are there. The first one, which is known as oblique projectile motion. The second one, it is known as horizontal projectile motion. And the third one, it is known as inclined plane projectile. Oblique projectile, it means what? Projectile is thrown at some angle. Horizontal projectile, it means projectile is thrown from some height. Inclined plane projectile, it means that projectile is thrown from some inclined plane. These are the examples of the projectile motion. Understood? The second part, Relative motion. First case of relative motion, Riemann problem. We will discuss the shortcut. There is a shortcut for Riemann problem. Riverman problem. There are two cases into the Riverman problem and we are having the shortcut. And the last case goes to circular motion. Among them, uniform circular motion UCM, non-uniform circular motion NUCM. So this is a chart of 2D. The circular motion, uniform circular motion, non-uniform circular motion can be taught separately into the work energy and power chapter. Don't get worried. In today's session, we are going to review projectile motion and types of projectile motion, relative motion, and I'm going to give you all the shortcuts for Riverman and the Riemann problem. See, projectile motion is all about direct formula. You have to understand the concept once, apply formula, get the answer. Understand the concept once, apply the formula, get the answer. Understand the concept once, apply formula and get the answer. Riverman and Riemann problems are like that only. Understand the sum, identify the case, apply the formula and get the answer. Identify the sum, understand the case, apply the formula and get the answer. Arey, everything is systematic, yaar. And this is just an students always need in a last minute things. They are always having a thought. They are always having a thought, right? ऐसा तो क्या करें? Immediately, everything should scroll into my mind. And through mind maps, each and every topic is going fast. And you are able to, you are capable to remember. You are capable to scroll each and everything and memorize it. So for them, mind map is the best technique, right? Right? Yeah. Important thing with the preparation. See, whenever you are appearing into the Neet examination, the important thing into the presentation, the preparation is in the exam is, it is important to remember everything. सही time पे सही चीज, right time, right moment, right things should come up into your mind. And this always happens with, right, whenever you do the more amount of the revision. Yes, the right moment, if you are able to recall things, understood everyone? Okay, so now can we move forward to the concept of oblique projectile motion? right? I want to ask you all one thing. You all are really enjoying this session, na? At least your knowledge is getting enhanced. At least your knowledge is getting polished before and after this lecture. You all are feeling good, na? Because see, this is what we are doing in English. Suppose just imagine if this thing goes in Hindi, right? So you can imagine the level of this session, right? I can understand very less students are there, but it's okay, right? We are good in whatsoever the students those who are present into this class. Because see, 2 hours of the class, see how time flies. Only 5 to 7 minutes are remaining in 2 hours of the class, right? Oblique projectile motion. See, this is very simple. Oblique projectile is quite simple. Classroom, teacher, कौन है? Who's doing mischief? Focus. Just write down what I write. Do it. Who is there? This happens with everyone. Yes or no? We are having Yakeen English batch, pure English, right? That will come, and rest of the details. Okay, new batches are coming this year, but let's see. Okay. Now we are coming back to the same example. You all are this whatever happens into the school life, and we are also damn right. We are also like we are even a stubborn peoples that we never used to stop harassing our school teachers, and now again teacher is like projectile. He throws a chalk to a student. Anna. Teacher should be like, into the classroom. Generally, it happens whenever she or he used to write it into the right board. Okay, this is the right moment for the students, an opportunity, right? It is an opportunity for the students to do an right mischief. So whenever teacher used to write, and teacher behaves like and throws chalk. Chalk is thrown at some angle with respect to ground. It travels the trajectory. This kind of the motion is projectile. Understood, everyone? This kind of the motion, it is what? Projectile. Okay. I must say it is a, now see, as you all know, this is a motion in 2D. As you all know, this is motion in 2D, right? Motion in 2D. So here, when you are resolving the components of u, this will be u sine theta. Two types of motions are involved. One into the horizontally x direction. Two types of motions are involved. The resultant of horizontal and vertical is projectile. See, it is a 2D motion. Once you are able to understand the concept, now you will understand everything. Are we having any kind of the acceleration to increase or decrease the u cos theta? Are we having any kind of the acceleration into the horizontal direction, right? Are we having any kind of the acceleration in the direction of u cos theta or in the opposite direction of the u cos theta? No. It means acceleration along the x direction is 0. The nature of the horizontal motion is uniform. The nature of the horizontal motion is what? Uniform. The example that I gave, it is not to disrespect teachers. It was just a comic moment to explain the example into the most convenient way, because this is a physics, right? So being a teacher, I can't hurt the sentiments, right? So it was just a disclaimer, just for an understanding purpose, right? So horizontal motion is uniform. Now see, there is a gravity. Gravity is there to decrease the u sin theta and again increase it. So if I am talking about the nature of the vertical motion, acceleration is there. So vertical motion is uniformly accelerated motion. Understood? So what is the nature of the horizontal motion? Uniform. What is the nature of the vertical motion? Uniformly accelerated. Resultant of this two is oblique projectile. This is the actual concept. This is an actual logic behind it. Now suppose, see now, generally whenever the oblique projectile is taught, okay, they used to teach about the direct formulas, and they said formula based questions are, I am following a different approach. If the projectile is a resultant of horizontal and vertical, it means the displacement is also the resultant of horizontal and vertical. Horizontal is uniform. All the formulas of the uniform motion I can apply in horizontal. Nature of the vertical motion is uniformly accelerated. All the formulas of the uniformly accelerated motion I can apply here. See, this is the displacement vector. Velocity into time is distance. For vertical, u sin theta minus half gt square j. It became easy or not? Everyone, those who are live. Resultant of this two is projectile. Velocity into the horizontal direction plus velocity into the vertical. Velocity into the horizontal is constant. Velocity into the vertical, g is decreasing. U sin theta minus gt. These are the two equations, right, from which trajectory, range, max height, all the spatial cases of the oblique projectile motion are defined from these two cases only. From these two formula, everything into the oblique projectile motion is defined. I will tell you by solving each and every question. Shall we start, everyone, those who are live? So you have to just remember these two formulas. So you found a different approach or not? Everyone, those who are live, you found the different approach for the oblique projectile motion or not? right? A particle is projected with the velocity v so that its range on the horizontal plane is twice of the height. Range is equal to twice max height. If J is accelerated due to gravity, then range is what? If you want to define the equation of range, you all know the formulas, na? See, R is equal to 4h by tan theta. Tan of theta, that is equal to 4h by R. R is twice of h max. Tan theta we got it as 2. If we are following triangular method, sin theta will be 1 by root array. Cos theta will be 1 by root 5. Sin theta will be equivalent to 2 by root 5. Okay. So using this formula, we found sine, cos, tan and everything. Now what we need to find? We need to find the range. So R is equal to u cos theta, u sin theta whole divided by G. So R is equal to u square into 2 by 5G. Understood everyone? And range is given as twice of max height. This is only the answer. Understood everyone? There is a misprint into the option. 2 should appear. Okay, there is a misprint into the option. Sorry for that. Answer is 2u square by 5g. Understood everyone? Answer is 2u square by 5g. Okay, this is given. This is the formula. We replaced given data into the formula. We got the angle. This is the angle of projection. This is the angle of projection. लास्ट में फॉर्मूला शीट मैं फॉर्मूला शीट दे दूंगा, right? Don't get worried. See, this is the given data. This is the formula. We replaced data into the formula. We got the angle of projection. If you want to find the range, angle of projection is needed. Now see, we found our angle of projection, but in formula of the range, we are having sine and cos, and we got answer in 10. So I use the trigonometry identity, the fundamentals of the trigonometry. From 10, I found sine and cos. Right? And I just replace into the formula of range. Understood everyone, those who are live? You can solve with the range height formula also. It's not a big deal. But right, you are going to reach onto the angle of projection only. Suppose if you are going to replace the range and height, you are going to reach up to angle of projection only. Understood? See, projectile is thrown with the initial velocity. What is the horizontal range? See, velocity vector is given. Yes or no? हाँ मिल जाएंगे ऐप पे, notes will be given. This is u cos theta. This is u sin theta. What is range? U square sin theta cos theta by G. Right? So it is 6 into 8 by 10, 48 by 10, 4.8 meter is the range. See, velocity vector is given or not, everyone. So question becomes easy or not? Question becomes easy or not, everyone, those who are live. The maximum range of the gun. See, whenever this word is used, the maximum range, it means projectile is fired as 45. Whenever the maximum range word is used, it means the projectile is fired at 45. And range maximum always becomes angle of the projection always becomes 45 into the case of the maximum range, and this becomes u square by 2g. So you have to just replace 16 into 10 to the power 3 into 2 into 10 is equal to u square. 32 into 10 to the power 4 is equal to u square. So can we get the muzzle velocity of the shell or not? Is it easy or not, everyone, those who are live? Notes will be uploaded. See, there is one link given below into the description. There is one link, right? Whenever you're going to click on that link, it will direct to you an app. In that app, all the notes will be available. Okay, Santosh Pitambre. Understood, everyone, those who are live? The range of the horizontal projectile is, okay, this will be easy. Projectile is fired with velocity u at angle theta. If initial velocity is doubled, range is directly proportional to sine 2 theta. Or you can say range is, as the angle of projection is same, range is directly proportional to u square. Okay, nice lecture, sir. Thanks, beta. Thanks a lot. R1 by I2, that is equal to U1 square by U2 square, right? So it is 1 by 4. So R2, that is equal to 4 R1. Understood? Is it easy or not? Everyone, those who are live. See, this is important. Now I am going to give you all the shortcut. See. These are the two equations of the trajectory of the projectile motion. These are the two equations of the trajectory of the projectile motion, right? So if the equation is given, they are telling us to calculate generally maximum time. The questions are asked from the second part only, right? So if I am making 16x common, right, then it will be 1 minus 5x by 64. 16x common, 1 minus x by 64 by 5. If I'm comparing this to x tan theta, what is the range? 64 by 5. What is the range? 64 by 5. No DPPs. Is it easy or not? Everyone, those who are live. Now it is important to discuss the shortcuts of the riverman and rainman problem. Right? Right? There are two cases into the riverman problem. The first, that is the shortest time. And second case is the shortest distance. You have to understand the concept logically once. The rest is shortcuts. Lots of shortcuts are there here. Understood, beta, everyone? B is the width of the river. In both of the cases, the agenda would be remaining same. We have to cross the river. In both of the cases, the agenda would remain same, that we need to cross the river. But here the agenda would be we need to cross the river in the shortest time, and here in this case the agenda would be to cross the river with the shortest distance. Here the swimmer becomes stubborn, here swimmer acts like smart. Twelfth new batch announcement will be done soon. So here what happens? This is how river flows with respect to ground. Here in the both of the cases, the shortcut is you always have to see the thing that appears to observer on the ground is truth. If you are going to stick on this statement, right? Only the observer on the ground can see the truth because he is on the ground and he becomes the inertial frame. Okay. So this is the velocity of the river with respect to observer on the ground. Now here swimmer is standing. What he thinks? I want to cross the river. I want to cross the river, but into the shortest time. No matter at what point I am going to reach onto the opposite side. Doesn't matter. My agenda is to cross the river into the shortest time because I'm scared of the water. Okay. If I would reach at this point, that point, I'm not interested. What I have to do? I will jump perpendicular to the river Santosh, things will be revealed here. Please focus on the concept right now. What swimmer will do? He will jump perpendicular to the river flow. Velocity of man with respect to river. He blindly jump perpendicular to the river flow, but slowly, river is drifting. He is swimming perpendicularly, but a river drifts. He is swimming perpendicularly, river drifts. So he thinks with respect to river he is going perpendicularly. Actually, rivers drifts him, and this truth is only seen by the observer. As of that reason, this is the velocity of a man with respect to ground. By this approach, he reaches to the opposite side, but he is having the drift. He reaches to the opposite side, but our agenda was not to reach at the point B, but instead of that our agenda was to reach onto the opposite side. As of that reason, he might have some drift. Now here the shortcut starts. Tan theta, that is VRG VMR, sin theta VRG VMG, cos theta VMR VMG. VRG is D whole divided by B, D by under root of B square plus D square, B by under root of B square plus B square. Okay, so this is a shortcut. This is the shortcut. Understood everyone? Those who are like this is the shortcut. Whatever the data it is given, just pluck out that data and replace into the equation to get the answers. Right. Now suppose if you want to calculate the time of the journey, if you are having the data of VMG, right, divided it by under root of B square plus D square. If you are having the data of VRG, divided by drift. If you are having the data of VMR, divide by the width of the river. From this equation directly you can calculate the time also. Suppose if you want to calculate the length of the journey, this is the length. From this direct formula based questions are going to come. Okay, so this is the first shortcut of the shortest time. Understood everyone? Those who are live can have the answers into the comment box. Now swimmer thinks what swimmer thinks? He want to start from point A only and want to reach exactly at the opposite point. Now he want to experience new things. Right? Now he want to experience new things. So exactly he want to start from point A. So this time what happened? River was flowing into the same direction, VRG. This time what he thought? He jumped at some angle with respect to the river flow. In previous case, he jumped perpendicular, river drifted. He swimmed perpendicular, river drifted. In this case, what he did? He jumped at angle, river drifted. He jumped and swam at some angle and river drifted. like this way. When he is inside the water, he feels like he is moving at some angle, but truth is seen by the observer on the ground, and he sees the object is the river is drifting the swimmer, and he is traveling onto the straight path, swimming onto the straight path, right? So this will be V mg. Again, theta, this is the width of the river. Okay, this was the drift that he was about to have. Tan theta, that is equal to Vrg by Vmg. Sin theta, that is equal to Vrg whole divided by Vmr. Cos of theta, that is equal to Vmg by Vmr. D by B, d by under root of b square plus d square, b by under root of b square plus d square. Again, if you want to find the time of the journey, if Vrg is given, have d. Okay, if Vmg is given, have b. If Vmr is given, under root of b square plus d square. No question is going to come outside from this, right? Within 1 hour, you will find the notes. There will be a link into the description. Through that, you will be able to find the notes. So, I want to ask you all, I want to ask the number of the students, those who are watching this class live. Nothing extraordinary apart from this is going to come. So, do you find this shortcuts helpful or not? Everyone, those who are live. So this is the shortcut for the riverman problem. Now that comes the rainman problem. This is my 6th hour of today's live class. See, it's burning. Now I'm going to give you all the shortcut for the rainman problem. See, rainman problem, you only have to follow the single approach. What happens to the man when he is stationary? What happens to the man when he is moving with the velocity? When the man is stationary, rain is falling vertically. When he moves, rain appears at some angle theta. So the shortcut lies in all of those cases. You have to only calculate how rain appears to moving man. In all of those cases, you only have to calculate how rain appears to the moving man. Understood? Right. Let us take in one example. Okay. We will see this thing into the examples. Okay. Chalo. Let's start. Raindrops are falling down vertically at 4. for a person moving forward at 3, see, velocity of a man with respect to velocity of a rain with respect to man, velocity of a rain with respect to ground, velocity of a man with respect to ground. Rain is falling downward, negative of 4j. Man is moving towards the right, positive of 3i. So what is the velocity of rain with respect to man? Negative of 3i minus 4j. Plot this on the graph. Negative 3i, negative 4j. This is how rain appears to moving man. Against to do this, he has to hold the umbrella. Understood, everyone? So in all of the cases, you have to calculate how rain appears to moving man. How rain appears to moving man. How rain appears to the moving man. Answer is 5. You have to find the magnitude of it. This is one and the same. A man want to cross the river 600 meter wide flowing. See, he want to cross the river into the shortest time. Direct data is given. If it is given shortest time, directly go on to the shortcut of the shortest time, apply the formula, get the answers. What is the path length covered? See, shortest time. Can we use this formula? See, width is given, river velocity, see, VRG by VMG is equal to, or you can say, you can use this equation also. Because we need to find the length, we need to find this vector. Okay. VMR by VMG is equal to B by under root of B square plus D square. Instead of that, you can use length. Replace values, get the answer. Replace the values, get the answer. Understood, everyone, those who are live? So are these shortcuts helping or not? Person can move in still water at 5. River moves with 3. Shortest distance. What is the time? Sorry, this is the case of upstream and downstream. Sorry. Okay, upstream and downstream. Sorry. No. This we can solve it by yourself. Some questions I have kept for you all to practice. Some questions I have kept you all for practice into the notes that will be available into the notes, and we are limiting the session up to here only. Okay, because extending the session beyond this, right, it will be like injustice with you all. Your eyes will get strained and everything, right? So this much is enough. Tomorrow we are going to come back with the Newton's law of motion, and we are going to solve more than 50 sums into the sessions, right? Understood? सुखमन बेटा कराया तो सही. Supan, we did that na beta. We did that na. You can see the explanation, direct shortcut we used, right? In this Neet, right, the topics what we have discussed in the Neet, this is a shortcut of shortest time. In shortest time, he swims perpendicular to the river, but river drifts. In case of shortest distance, he swims at the angle and river drifts him straight. Okay. Upstream and downstream. Okay. Upstream and downstream. While moving upstream, we are going against the river. So time is calculated as downstream, right? Velocity of river and velocity of boat. So time will be VR plus VB by distance. The approach of plus and minus is only there. Upstream we are going against the river, downstream we are going with the river. So when you go downstream, velocities with the river are added. When you go upstream, velocity to the rivers are subtracted, because we are moving into the opposite direction. Okay. If all students feel that you found something good, if your knowledge has been enhanced before and after this session, right, please write down one comments beneath the box. Right. Please write down the comments beneath the box. Right. If you like this sessions, it is really fruitful. Right. Tomorrow we will start with the NLM. Right. Okay, guys. So that much is enough for today. This is your own physics educator, Indrajit Singh. Right. Signing off from the desk. Bye bye. I will be waiting for all of your right comment. Okay, beneath the video. So this is your own physics educator, Indrajit Singh, signing off from the desk. Bye bye. Sat Sri Akal and Namaste from my side. Bye everyone. Stay at home. Stay safe. Stay healthy. Prepare well for NEET 2025.